Welcome to the YouTube channel, Mr. Rafa Online Tuitions. Please don't forget to subscribe to the YouTube channel, Mr. Rafa Online Tuitions, and click on the notification button so that whenever I upload the video of this nature, you'll be able to watch and learn. Today, we are here to crack down the codes of chemistry, science, paper 2, 2024 GCE final examination. Section B carries 45 marks. B1. A box of chemicals in a laboratory has the following symbol attached to it. A symbol of fire. So A1, describe the nature of chemicals in a box related to the symbol. So this symbol, it shows that the chemicals that are in a box catches fire easily. So that's what it means. Or if you want, you can say the chemicals are highly flammable. B2, write a laboratory rule that is observed when handling chemicals in this box. So number 1, laboratory rule that should be observed when handling the chemicals that catches fire easily is that number 1, these chemicals, they must be stored in a well-ventilated area. Store chemicals in a well-ventilated. So store chemicals in a well-ventilated area. That is a laboratory rule number 1. So these chemicals must be stored in a well-ventilated area. Number 2, you have to store these chemicals in a cool place. Store in a cool place. In a cool place. So those are the laboratory rules that must be observed when handling chemicals that catches fire easily. Or number 3, we can even include the third one, store the chemicals in fireproof cabinets. Store chemicals in fireproof cabinets. The third one is store chemicals in a fireproof cabinet. B, when a bottle of ammonia is opened, within a few minutes, its smell spreads throughout the laboratory. B1, name the process responsible for the evenly spreading of the smell of ammonia solution. So the process, it is called diffusion. So diffusion, it is the process that is responsible for the spreading of ammonia particles. B2, describe the process responsible for the even spreading of the smell of ammonia solution. So the process that is responsible, it is diffusion. So now let us describe diffusion. You need to understand that diffusion, it's a movement of particles from the region of higher concentration to the region of lower concentration down the concentration in gradient. So diffusion, it is the movement of particles from the region of higher concentration. To the region of lower concentration. Down concentration gradient. Part 3. Relate the evidence which the process named in B1 provides to the kinetic theory of matter. So the process that is named in B1, it is diffusion. So relate the evidence which diffusion provides to the kinetic theory of matter. So diffusion, it provides to the kinetic theory of matter is that matter is made up of tiny particles. Matter is made up of tiny particles that are in a continuous random motion. Random motion. So B2, the following diagram shows a piece of apparatus used in the laboratory. So this is the piece of apparatus. So part A, name the piece of apparatus shown in the diagram. So the piece of apparatus, it is the separating funnel. Separating funnel. So the separating funnel, it is used to separate what we call immiscible liquids. So liquids that cannot dissolve each other. So we use this apparatus. So now B1, identify property of a mixture separated by the apparatus named in A, which is the separating funnel. So these immiscible liquids, one of the properties that they have is that, or what even makes it possible for them to be separated, is that they've got different densities. Very important, they've got different densities. For example, vegetable oil and water, when you mix them, automatically they are not going to mix, they are going to form layers. So the liquid which is less denser, it will be on top. The liquid which is denser, it will be on the bottom. So that property of different densities makes it possible for them to be separated. So they have different densities. Of different densities. So that is one of the properties. B2 suggests the names of two liquids that can be separated by the piece of apparatus shown in the diagram. So vegetable oil, and water. If you want, you can say paraffin and water. So these are what we call immiscible liquids. Part C suggests two precautions that need to be taken to separate the mixture in B2. The mixture in B2. So if I want to separate vegetable oil and water, vegetable oil and water, or paraffin and water, so the precautions that I need to undertake is that, number one, I need to ensure that the tap is closed before the mixture is placed in the separating funnel. That the tap is closed before the mixture is placed in the funnel. That is number 1 precaution. Then number 2 precaution that we need to undertake when we are using this apparatus, we have to ensure that the mixture settles before draining. You have to ensure that it settles. You take time for the mixture to settle, then you begin to drain. So to settle before draining. Then we can also add the last one. So clean the separating funnel. Clean the separating funnel. So you can choose any of the two. B3, the following diagram shows the electronic configuration of the ion of an element M. So this simply means, the positive here, it simply means that this element M, it has lost 2 electrons of its outermost shell. So B1, draw the atomic structure and write the electronic configuration of the neutral atom of M. So now the neutral atom that we are going to draw, it is before it has lost these 2 electrons. So now let us draw the atomic structure. So from this structure, we will just add the outer structure containing 2 electrons it has lost. Remember that this is an ion, but we need to draw the atom. So the neutral atom, in other words, before it had lost these 2 electrons. So it has 1, 2, 3 plus this, it has 4 shells. So the last shell, it is going to have 2 electrons. So they have atom M. So electronic configuration. So remember that the first shell, it has 2 electrons. The second shell, it has 8 electrons. The third shell, it has 8 electrons. And the last shell, it has 2 electrons. So part 2, give the name, group, and period of element M. So the name, the group, and the period of element M. So here you go on the periodic table so that you check the group where it is coming from, the period, then you'll be able to know even the name. So this one, it has 2 electrons in its outermost shell. So it is coming from group 2. Then we have 1, 2, 3, 4. We have 4 shells. So that simply means that it is coming from period 4. The number of electrons in its outermost shell tells us the group where it is coming from. So it is coming from group 2. Then the number of shells, we have 1, 2, 3, 4, 4 shells. So it is coming from period 4. So let's go on the periodic table and check which one is in group 2, period 4. So this is the periodic table. So this is group 2. And now let's check period 4. So we have period 1, period 2, period 3, period 4, group 2. So it is calcium. So calcium, it has the relative atomic mass 40. Then the proton number, we have 20. So it is calcium. So that is the name. So remember that 2 plus 8, that is 10, 18, 19, 20. So that is the proton number. So the proton number, it is 20. Part B, compare the reactivity of an atom of M and an ion of M. So there is a difference between the two. An atom of M, this one it is in a natural state. Then when atom M loses the number of electrons in its outermost shell, remember that this is a metal. So a metal forms an ion when it loses electrons in its outermost shell. Then it becomes an ion. So that simply means that this element, it will lose 2 electrons of its outermost shell. Then it becomes what? It becomes an ion. So now what is the difference between atom M, which is this one, and an ion? In other words, when it loses 2 electrons in its outermost shell. So what is the difference? So the difference is very simple. An atom, it is very reactive when it is unstable. Then an ion becomes less active when it becomes stable. Remember, why do atoms form a bond? They form a bond for them to be stable. Once they form a bond, they become stable and they become less reactive. So atom M is reactive because it is unstable. Then ion M is unreactive because it is stable. So that is the difference between an atom and an ion. B4, salts are substances that have many methods of preparation. A, iron 2 chloride can be prepared by reacting substance X and dilute hydrochloric acid. A1, which reactant should be in excess? So the substance that should be in excess, it is substance X. It is substance X. Substance X should be in excess. Then A2, why should the named reactant in B1 be in excess? It should be in excess to neutralize the acid. To neutralize the acid. Or if you want, you can say that to ensure that the acid is completely used. So to completely use the acid. So that is the other option that you can take. Number B1 suggests a suitable reactant as substance X. So for us to choose a suitable reactant, we have to look at the product that we have been given. Remember the question. Iron 2 chloride can be prepared by reacting substance X and dilute hydrochloric acid. So meaning this substance X, it must contain iron. So which is the iron metal? Which is the iron metal? So iron. Then B2, write a balanced chemical equation for the reaction between substance X suggested in B1 and dilute hydrochloric acid. So there we have iron metal. We have iron metal plus hydrochloric acid. Dilute hydrochloric acid. Remember that we are going to have. So we are going to have iron. Remember that it is iron 2. So we are going to have iron chloride plus hydrogen gas. So remember that it is iron 2. So what we have, it is iron 2 chloride. So when iron reacts with hydrochloric acid, what we are going to have is iron 2 chloride plus hydrogen gas. Remember the chemical reactions of acid. Whenever an acid reacts with a metal, what we are going to have, it is a salt and hydrogen gas. So B5, 10.5 grams of sodium hydroxide was reacted with dilute sulfuric acid according to the equation. So sodium hydroxide plus sulfuric acid, we are going to have sodium sulfate plus water. So how do we balance the chemical equations? It is very simple. So this side we have 1 atom of sodium. This side we have 2 atoms of sodium. So I will ensure that even this side I have 2 atoms of sodium. So what do? I'm going to place 2 in front of sodium hydroxide. So that is a 2. So this simply means that sodium becomes 2, sodium is to this side. So sodium is balanced. So oxygen is affected. So oxygen becomes 2 plus 4, 6. Let's look at this side. We have 4 plus 1, which is 5. Ensure that even this side, oxygen becomes 6. So what do? We are going to put a 2 there, so that oxygen becomes 2 plus 4, 6. Hydrogen, this side it is 2 plus 2, 4. This side 2 times 2, 4. It is balanced. So we have B2. Use the balanced chemical equation to calculate the mass of sodium sulfate formed. So that is the balanced chemical equation. So now, what is the demand of the question? So the demand of the question is calculate the mass of sodium sulfate. So this is sodium sulfate. So I'll put X below sodium sulfate. Then what have we been given? So from the question, we've been given 10.5 grams of sodium hydroxide. So I'll write 10.5 grams below sodium hydroxide. So from there now, I'm going to calculate the total molar mass of the compounds concerned. So the compounds concerned, it is sodium sulfate and the sodium hydroxide. So let us calculate the total molar mass of sodium hydroxide. So we have sodium hydroxide. So in this case, we are saying total molar mass. So inclusive these two. So this simply means that we have 2 atoms of hydrogen times the mass of hydrogen. So how do we take the mass number? So the mass number, the mass of hydrogen is 1. So the mass of oxygen, it is 16. So the mass of sodium, is 23. So the mass of sodium is 23. So we have 2 times 1, which is 2. So oxygen, we have 2 times 16, which is 32. So 2 times sodium, it is 23. So which is 46. So the total molar mass is 2 plus 32 plus 46. So the answer is 80. So 80, that is the molar mass of sodium hydroxide. Then we have sodium sulfate. Sodium sulfate, we have 4 atoms of oxygen. So 4 times 16, which is 64. We have 1 atom of sulfur, so we have 1 times the mass of sulfur, it is 32. So which is 32. We have 2 atoms of sodium, so it is 2 times 23. 2 times 23, which is 46. So there, 64 plus 32 plus 46. So 142. So we have 142. So from there, I'll cross multiply. So 80 times x, it is 80x. So 142 times 10.5. So the answer is 1,491. So you divide throughout with 80, throughout with 80, 80 goes, x is equal to, so 1,491 divided by 80. So the answer is 18.6375. So the answer is 18.64 grams. What type of reaction is involved in the equation? So in this equation, we have sodium hydroxide plus sulfuric acid. We are going to have sodium sulfate and water. So this is a base and this is an acid. So what we are going to have, it's a salt and water. So the reaction between a base and an acid, that reaction, it is called neutralization reaction. So neutralization reaction. An element is in group 1 of the periodic table. Another element is in group 7. Write one property of the compound formed when element A and element N react. So now you need to understand that group 1 elements, they are metals. Group 7 elements are non-metals. So when a metal and a non-metal, they react, they are going to form what we call an ionic bonding. So you look at, in those contexts, what is the property of the ionic compounds? So number 1 property of the ionic compound is that they've got high melting and boiling points. Number 2 property is that they are non-volatile. Non-volatile, it means they cannot evaporate. Then number 3, we can even include the third one. They conduct electricity when in a molten form. In other words, when in a liquid form. Conducts electricity in a molten form. So that is another property that we can include. Part B, what type of bonding exists in the compound formed when the 2 elements react? So when a metal and a non-metal react, they form what we call an ionic bonding. Ionic bonding. So what is the other name for ionic bonding? The other name for ionic bonding, it is called electrovalent. Electrovalent bonding. That is the other name for ionic bonding. But see, how does the reactivity of elements in group 1 differ from that of elements in group 7? So now you need to understand that in terms of the reactivity of group 1 elements. Group 1 elements, these are metals. So these are group 1 elements. So for group 1 elements, as you go down the group, the reactivity increases. So that simply means that the most reactive element in group 1, it is francium. Francium is the most reactive element in this group, and it is the most reactive element on the periodic table, because group 1 elements are the most reactive elements on the periodic table. And as you go down the group, the reactivity increases. But as for group 7, so these are group 7 elements. These are non-metals. Okay? So for group 7, as you go up the group, the reactivity increases. So the most reactive element in this group, it is fluorine. So fluorine, it's the most reactive. Why? As you go up, the reactivity increases. In group 1, as you go down the group, reactivity increases. On the other hand, group 7 reactivity increases as you go up the group. B7, metallic bonding accounts for most of the physical properties of metals. A, with reference to metallic bonding, explain why most metals have high melting points. So the reason is very simple. The reason why metals have high melting point is very simple. It's because of the strong electrostatic force of attraction between their cations and the delocalized electrons. So what does it mean? What it means is that the electrostatic force of attraction, it is a force that holds the particles or the cations in a metal and the delocalized electrons. So now that force, it's the one that we call electrostatic force of attraction. So that is the same force that causes a metal to have high melting point. Because of the strong electrostatic force of attraction between their cations and delocalized electrons. Hence, they require a lot of heat energy to be broken. Part B, draw a diagram to show metallic bonding in the zinc metal. Metallic bonding in the zinc metal. Remember that a zinc, it has a charge of +2. So for us to show the zinc ion, we are going to use +2. So negative electron So when you are drawing, you need to ensure that they are not, you need to ensure that they are in a system whereby if there is a positive charge, the next one should be a negative charge. So positive charge, negative charge, positive charge, negative charge. That's a system that you need to uphold. So now you have, what does this mean? So this is, you need to label. This is delocalized. Delocalized electrons. Then what is this? This is zinc ion. So if you want, you can say C of electrons. If you want, you can say C of electrons. Part C. Elena carried out the following experiments. In experiment 1, 5 grams of powdered zinc, and in experiment 2, 5 grams of granules of zinc were each reacted with equal volumes of dilute hydrochloric acid, both of the same concentration, for 15 seconds. The reactions were not yet completed at 15 seconds. C1. In which experiment was a large volume of hydrogen produced? Give a reason for your answer. So here we have 2 experiments here. In experiment 1, there is 5 grams of powdered zinc. In experiment 2, 5 grams of granules of zinc. Okay, so in here they've got the same concentration, but the rate of reaction was different. So in an experiment where the large volume of hydrogen was produced was in experiment 1. So why in experiment 1? Because we had the powdered zinc. Okay, so the powdered zinc increased the large surface area for the reaction. So therefore, there we're going to expect a quick reaction. Experiment 1. So give a reason for your answer. So the reason for our answer is that powdered zinc provides a large surface area for the reaction. So now the other explanation that we can include there is that In a powdered zinc, there are smaller particles, more atoms or molecules which are being exposed in the reaction. So this results in more effective corrosion in a given what? In a given time. So in other words, another reason that we can give is that in powdered zinc, there is smaller particles. So smaller particles, more atoms that are exposed for reaction. So this results in more corrosion. Part 2, what could be the effect of reducing the temperature of the acid in the reaction in C1? So now when we reduce the temperature of the acid, so the rate of reaction will decrease. So decrease in the rate of reaction. B8, the following diagram shows the laboratory preparation of a gas and its correction. So we have dilute hydrochloric acid, granules of metal Y, then we have gas X. A, identify, part 1, one error in the setup in the diagram shown. So one error that is observed here is that the Fisto funnel here, it has no tap. That is error number 1. There must be a tap here. Error number 2, the Fisto funnel, it must be long enough to dip in the solution there. So if at all it is not dipped there, the gas that will be produced will be going that side. So error number 1. So error number 1, Fisto funnel has no tap. That is error number 1. If you want, you can say that the Fisto funnel is not dipped in the reacting substance. Fisto funnel is not dipped in the reacting substance. That is error number 2. So the Fisto funnel, it must dip in the reacting substance to prevent the gas from going this side, the gas which is produced. So when the gas is produced, it must go through the delivery tube, then it goes there. But if it is not dipped there, it will go through the Fisto funnel. So that is the reason why it must dip in the reacting substance. So identify gas X. So gas X, remember the reaction. The reaction between a metal and an acid. The gas that is produced, it is hydrogen gas. B. Predict what will be observed if metal Y is replaced with copper. So what will be observed when metal Y is replaced with copper? So remember that copper does not react with dilute hydrochloric acid. So now these bubbles, these are bubbles, these bubbles so remember that in here there are bubbles. So these bubbles, they represent the gas which is formed. So when this metal white is replaced with copper, these bubbles will not be observed. So the bubbles will not be observed. So now the other language that we can use is there is no effervescence. Remember, if you have watched my previous video on section A of the same paper, you'll be able to understand what is effervescence. So no bubbles observed. So the reason is that copper does not react with what? With the dilute acid. So no bubbles observed. In other words, no effervescence. No effervescence. But see, with reference to air pollution, compare the use of ethanol and diesel fuels. So ethanol, it does not pollute the environment. Why does it not pollute the environment? It's because it produces less carbon dioxide. So ethanol reduces the emulsion of carbon dioxide and carbon monoxide. Because it burns completely in oxygen. On the other hand, diesel produces more carbon dioxide and carbon monoxide. So that is the way it is. So with reference to air pollution, compare the use of ethanol and diesel fuels. So ethanol reduces the emulsion of carbon dioxide and carbon monoxide because it burns completely in oxygen. On the other hand, diesel produces more carbon dioxide and carbon monoxide. So ethanol, it's a better fuel as compared to diesel. The last question on section B. The following table shows some of the fractions of hydrocarbons obtained from fractional distillation of liquid oil. So we have fraction A, the boiling point ranges from 20 to 60 degrees. Fraction B, 60 to 110 degrees. C, 110 to 200 degrees Celsius. Then D, 200 to 360 degrees Celsius. Then part A, which fraction contains the longest chain? Give a reason for your answer. So the fraction that contains the longest chain, it is D. Fraction D. So give a reason for your answer. So the higher the boiling point, the increase in the number of carbon atoms due to the increase in the strength. So that is the reason. So the reason is very simple. So the higher the boiling point, the increase in the number of carbon atom due to the increase in strength. The higher the boiling point, the increase in the number of carbon atoms due to increase in strength. Part B, decane can be cracked to produce hexane and one other hydrocarbon D and one other hydrocarbon T. B1, deduce the chemical formula of T. So what is being cracked here? It is decane. Then it gives us hexane. And hydrocarbon T. So deduce the chemical formula of T. So you just have to subtract 10 minus 6. We remain with 4 carbon atoms. 22 minus 14. We have 8. So the chemical formula, it is that one. Part 2, draw the displayed structure of formula T. So that simply means that if you get this one wrong, even this one, it will be wrong. So the first thing that you need to do, you need to identify in which family is this compound coming from. So this compound, it is coming from the family of alkenes, the unsaturated hydrocarbons. Okay. So which has a double bond between two carbon atoms. So we have a double bond between two carbon atoms. Then we have 8 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8. So that is the structure of hydrocarbon T. So what is the name of this compound, which has 4 carbon atoms? So this is what we call butene. It is what we call butene. So that is butene. Part 3, would you expect hydrocarbon T to undergo polymerization? Explain your answer. So hydrocarbon T, which is butene, it is coming from alkenes, which are the unsaturated hydrocarbons. So these, they undergo polymerization. Why do they undergo polymerization? Because they are unsaturated. It undergo polymerization. Explain your answer. Because it is the unsaturated hydrocarbon.